Okay, welcome back. So the last time we had talked about the differences between these base R data frames and tibbles, and we really saw that as far as doing row subsetting, there really wasn't much of a difference, if any difference. But the differences really showed up with the column subsetting, that the base R data frames are inconsistent in terms of, like, sometimes when you subset them, you'll end up with an atomic vector. Other times when you subset them, you'll end up with a data frame. But with tibbles, you're going to get a tibble every single time unless you specifically ask for via either the $ or the pull function or the double subset operator to say, give me the contents of this column, give me the information out of it as atomic information. Um, I wanted to talk about relational subsetting and how the relational subsetting is with there's the base R version over here and then the dplyr version over here, and I want to compare these and then give some philosophical comments on that. So this would be if I were going back to the atomic vectors lesson and the lists and tibbles lesson, and I didn't have access to dplyr, and I wanted to answer the question. We want to find data for all the females in the Framingham data set that are younger than the 75th percentile of the ages. Then these are the steps that I'd have to go through. So remember, there's 3 steps here. So the first step is find the columns that we care about and perform a logical, and then so find the columns we care about, and then do this this operator, the logical comparison operator, and then we're going to end up with a column of trues and falses, and then subset the rows down to that. And we said that using the filter command is going to be very similar to this, but it would be a lot cleaner. So let's walk through the steps that we would have to do to answer this relatively simple question. Okay, so the first thing is we're going to create a subset of the women. So we're going to create a subset tibble that is the tibble, but notice here I'm selecting, so I'm on the left-hand side of the comma, which means I'm selecting the rows where this condition is true. The condition being, take the column sex outside of the tibble. So I'm using the $ operator to extract it and compare it to the character string female. Is this equal to female? So this is going to return a set of trues and falses. So an atomic vector of trues and falses. And now I'm going to put that atomic vector of trues and falses in on the rows of the tibble. So I'm saying, give me, because I'm on the left-hand side of the comma, give me all of the rows where the sex column is equal to the value female with an uppercase F, and then save this as a subset called the Framingham women. Okay. Now, the next step would be, okay, so we've got all of the women in the Framingham data set. Then we say, okay, we want to find the 75th percentile for ages. So what do we have to do? We have to take out the age column. We calculate the 75th quantile and save this as a threshold. Then we perform another logical subsetting operator, and we say, okay, of the Framingham women, find the age column, and then compare this to our threshold and find. So again, this is going to return a logical indicator of trues and falses with the number of trues and falses values equal to the number of the rows of the women data set. So I've had to create a women's data set with this comparison up here, or this subsetting up here, and then I'm taking the age column out of that women's subset, and I'm going to compare it against this threshold for the 75th percentile, and then I'm saving this data set as another subset. So I had to subset to the women, then I had to subset to those under the 75th percentile, and so I have the Framingham young women tibble. And then, because I don't want to have all of this junk in my global environment, I need to remove the intermediary steps. This is the Framingham women tibble, and then also the threshold, and then I can inspect this. So I remember I started off with 20 records. And so this is obviously a fake, like an artificially contrived simple example. But right here, I say, okay, we want to find all of these women, and here they are. there are 9 records of the 20 that have women under the age of this 75th percentile cutoff. Now, look at this code, and we're going to compare this to the dplyr version. Take the data set, filter to the females, and filter so that their ages are less than the 75th percentile. That's it. Okay. I don't have to clean up my environment afterwards. I don't have to make these intermediary objects. I don't have to type Framingham Tibble DF $sex. And then Framingham women Tibble DF $age. And then again, Framingham women Tibble DF $age. It's just like so much typing that I have to do versus, I mean, look at these. That's it. Just 3 lines. Take the data set, find all of the females, then find all of the find all of the records where the sex at birth is equal to female, then find all of the records where the age is less than the 75th percentile for age. Done. Anyway. Some of you, well, anyway, so there's an example, and you see here that realistically, if you're writing code, you want to be writing this, you don't want to be writing this. You want to 6 months later come back and try to read and understand this. You don't want to 6 months later come back and try to read and understand this. You want to troubleshoot this for bugs and issues. You don't want to have to troubleshoot this for bugs and issues, okay? The more you type, the bigger your code is, the more chance that you're going to look at something and miss it. You're going to make a mistake and not see it, okay? So keep things simple. All right, here's another example. So this is, we want to find, so we've got the Gapminder data set. We want to find the 25 countries in the Gapminder data that had the largest infant mortality rate in the year 2010. Okay, so step 1. So this is using base R. So these are our rules that we picked up back in the atomic vectors and the lists and tibbles lesson. So we've got our, we're using Boolean subsetting again. We say, give me the year column as an atomic vector out of this tibble and compare it equal to 2010. So this creates a vector of trues and falses. Put that vector of trues and falses to the left of the column, meaning that we want the rows where this condition is true. Save this as a subset. Then we want to order this subset. So we want to say, okay, give me the column of infant mortality. So give me the column of infant mortality, and I want to sort it, but give me the positions of those rows. So this is an indicator. This is an index object, okay? So what this is saying is, if row number 1 is, so let's say there's, I don't know, 165 countries in the data set. Row number 1 is Afghanistan, and Afghanistan had like the 5th worst infant mortality or whatever, then that means that this value, this index, this is atomic index value, would have a 5 for number 1. So, and then that would be, let's see, is actually no, Afghanistan's not even in the top 10. So let's say it's I don't know, maybe 30 or something in 2010. So the first number that corresponds to the positional placement of Afghanistan. So Afghanistan is the first country, but it's not going to be number 1. So it's not going to be number 1 here. It's going to be whatever position it is in this ranking of infant mortality. And if it's the 30th worst country, then the number 30 goes right here. Okay. And then we say, okay, give me the worst 25. So I'm going to take the first 25 of these countries. So the 25 of the worst, whatever their positions are, and then extract these pieces of information. Okay, this is hard to explain. I'm not even sure I explained it correctly, to be completely honest with you. It's hard to read. It's kind of a pain in the butt, but we get our 25 countries that have the worst infant mortality. Now let's look at the same code with dplyr. Filter to the year 2010, arrange in descending order by infant mortality, and cut to the top 25 of them. That's it. We're done. Okay, so this is where I'm gonna wrap up the lesson. We've spent our time on this lesson. I hope that more than anything, you see a couple things. Number one, base R data frames are inconsistent in terms of the classes of the data objects that you're going to end up with. And two, I want you to see that dplyr code, particularly when you're allowed to use the pipe operator, you just get these nice clean data pipelines. And these clean data pipelines are the kind of code that if you open up this code in 6 months or you open up this code in a year, you would much rather see this code than seeing all of this code. Okay? Make your life easier for yourself. Now, there are some of you that you learned are in another department. You learned it from and I'm a statistician. I was trained, I have a PhD in statistics. I was trained in the statistics department. And so I know a lot of times how it works is that you get handed your code from a professor, or they had a previous grad student. There's like, here, use this code that my other student wrote and just replicate it and change one or two things, and we're going to keep working on this problem. But then that student, they didn't really, they were self-taught, and you're self-taught. And so you end up with this code that is just monstrously difficult to read, and it's horribly inefficient. And you never actually learned R. Really, what you did was you learned how to Google errors and keep beating the code until the errors go away. And that is not how you should write computer code. You should write computer code, and there's a whole lesson on this. We're talking about like the RStudio projects lesson, where you want to write code based on an outline. You say, all right, I want to start with this kind of data, I want to end with this kind of data, or I want to start with this and end with this result. And I'm going to outline the steps that I need to take in the middle, and then I'm going to write code based on this plan, not just say, oh, well, I don't know how to do this part, so I'm going to go Google it, find a solution, and then just shove it in here. And then you end up with this massive spaghetti code. Now, some of you like your spaghetti code, okay? Some of you are comfortable in your old way of writing R. And I'm not going to be able to pull you out of that. You are set in your ways, and there's not much I can do for you. You can't fill a cup that's already full, you know? But I'm giving you this as an invitation. If you're willing to try to unlearn the older way of thinking about R code, you may end up better off. Okay. Now, for those of you who've never seen R before, then you're fine. You're just learning all of this stuff new. You didn't know there were other ways to do this. There are many, many, many ways to write R code. There are many correct ways to write R code. There are many incorrect ways to write R code. Throughout this semester, I've tried to show you one of the correct ways to write R code. This is not the only way. There's an entire other competing set of packages called the data table ecosystem, and that's another way of writing R code that also has a lot of great strengths to it. The reason that we're doing it this way is because of the human readability. I want to take a group of students who are unfamiliar and sometimes even scared of working with their computers and get you to the point where you can do very, very powerful things with your computers in R. And for those of you that you're comfortable writing R code the same way that you've written it your entire life because you've had other classes from a statistics department or from somewhere else where you learned how to use R, that's fine. Whatever. If your code works and if it's well written, if it's organized, if you've got good comments explaining why you're doing what you're doing, that's fine. Okay. I may not be happy about it, but you have a system that works for you and you can extend it over time. You can build on it over time and other people can read it. However, if I look at your code and your justification for why you wrote what you did was, well, the code works, I will be very unhappy with you. That should not be the justification. That should not be the measurement of whether or not something is right or wrong, is if it works. The measurement of whether or not your code is right or wrong should be, can people read it? Can people understand it? Can people use it in the future? Can people fix it if it breaks? Not, oh, it works right now, even though nobody can read it, nobody can understand what it does. All right. So I am a little bit reasonably passionate about this. Please, if you're taking this class and you have the time to put into it, put some new tools in your toolbox. And I'm speaking specifically to the people that have learned legacy versions of R, older versions of R. I want you to take this opportunity to learn some more modern stuff. Alrighty then. That is the end of my pontificating. The next time that we see each other, we will be getting into character strings. So we'll see you soon. All right. Bye-bye.